All right, good evening, everybody. Today we're going to be doing practice and problem solving for simplifying expressions. I'm going to do all the odd ones today. That's going to leave the even ones for you. Well, number 7 starts with negative 2.8f plus or positive 0.9f negative 12 and negative 4. Remember, every term starts with a sign, basically positive or negative, then a number, let's just say like 4 or 7, and then it possibly a variable. It could be x, it could even be y, z. These variables could even be to a certain power if you wanted to, okay? For us to mix them, adding and subtracting, they have to have the same variable, in other words, the same letters, to the same power, okay? If there are any letters or any powers that are different, then you cannot add or subtract them. That is not the case for multiplication, which we'll find out later. But right now, for simplifying these addition and subtraction problems, they must have the same variable to the same power. Let's go ahead and work number 7. I can see that both these terms have f to the same power, okay? So to 0 power or to 1 power. So we're going to go ahead and combine them. We have 2.9 plus 0.9, or 2.8 plus 0.9. And remember, whenever we have numbers with two different signs, we take the big number, which is going to be 2.8, we minus the small number, which is 0.9, and we keep the sign of the bigger number. So since the bigger number is 2.8, we're going to keep that negative. And now we subtract, right? Since they're different, we're going to find the difference. Okay, but the sign will be negative at the end because the bigger number was negative. Well, I'm going to have to borrow one from over here, which turns us to 18, which leaves me with 1.9. So that tells me I have negative 1.9 f. But I'm not done there. I've taken care of these two terms, and now I've got to knock out these two terms. Now I've got negative 12 and negative 4. This time my signs are the same, and the rule is if my signs are the same, I add and keep the sign. So I'm going to add 12 plus 4. 12 plus 4 is 16. And since both of them are negative, my answer would be negative. So this would be minus 16. And there's nothing else I can do here because I can't combine an f with a regular number. So my final answer is negative 1.9 f minus 16. All right, let's go to number 9 now. Number 9 says 2n plus 5.5 minus 0.9n minus 8 plus 4.5. Again, let's get all the terms that are the same together. Well, first let's get the n's together, and we got 2n here. Are there any others that end in just n to the first power? Well, this one doesn't have an n, so I can't combine it with that. This one does have an n, so I can put minus 0.9n. And this doesn't have an n, and this one doesn't have it. So let's group these together. And now let's go see what we're going to add or subtract in the two. Well, the next one that has a variable has a p. So it has a positive 4.5. There is no other one with a p. So I'm going to say plus 4.5. And now I go to my numbers. I have a plus positive 5.5, plus 5.5. And then I have a negative 8 here, minus 8. And those are my numbers. Okay, so let's go ahead and combine our terms now. We got 2 minus 0.9. Again, we have two numbers with two different signs. We take the big number. The big number is 2 here, not 9, because this is 0.9, right? So 2, and then 0.9 we're going to subtract from it because the signs are different. Remember, we're going to keep the sign of the bigger number. The bigger number is 2, so it's going to be a positive answer. All right? Well, I remember that I have to put my decimal there, and I have to borrow one, and that's going to leave me with 1.1. So this is going to be 1.1n, and plus, oh, this was 45p. I should have put the p there. Plus 40 or 4.5 p. And then let's see, 5.5 minus 8. Again, we're going to take, since we have one that's negative, one that's positive, we're going to take the big number minus the small number, keep the sign of the big number. The big number here is 8 because this is just 5.5. That's 5.5. So this is going to be 8 minus 5.5. And since the bigger number is negative, that means my answer will be negative. Once again, I have to borrow, and that's going to give me a 5 over here and a 2 over here. So this is going to be negative 2.5 minus 2.5. Can I combine anything else? No, because I can't combine n's with p's with nothings. So my final answer is 1.1n plus 4.5p minus 2.5. All right, let's work our way down now to number 11. Which expression is equivalent to negative 5v plus negative 2 plus 1 plus negative 2v? Well, they're looking for us to give one of these expressions. So we know it's going to be one of these four answers. First, let's combine the terms that are alike. I'm going to start with negative 5v. Are there any other terms that have v in it to the first power? I see one over here that says negative 2v. So I can put negative 2v over here. And we're going to group these together. Now I'm going to look for the numbers because I don't see any other terms with variables in it. And I see a negative 2 and a positive 1. So let's see, minus 2 plus 1. All right? Okay. If I combine these together, I see that I have negative 5v minus 2v. Well, my signs are the same, and my rule goes, if my signs are the same, I add my numbers and keep the sign. So I know my answer is going to be negative, and 5 plus 2 is 7. So it's 7v. Then I have a negative 2 plus 1. My signs are different, so I take the big number, which is 2, minus the small number, which is 1. I keep the sign of the big number, that was negative, and 2 minus 1 is 1. So answer is negative 7v minus 1. Let's see if one of these are there. Look at there. Negative 7v minus 1. My answer has to be C. All right, let's go to number 13. The dimensions of a garden are shown. Write an expression to find the perimeter. And write an expression to find the perimeter. Well, the perimeter, as I remember, is how the distance around an object. So that means if this is 1/2 x minus 7, this has to be 1/2 x minus 7. And if this is x, then, well, that means that this is x. And now I'm ready to go ahead and work my problem, because what I realize is that I have 2 of these and 2 of these. So let's write that expression. First, I have an x and an x plus an x, right? And then over here, I have 1/2 x minus 7. So remember, we're adding all these together, plus 1/2 x minus 7. And since I have another one, I have to add that again. Add 1/2 x minus 7. And now it's time to combine terms. All right, over here I have an x and an x, so that's going to give me 2 x's. but then I have these half x's over here. So in actuality, I have x plus an x plus a 1/2 x, and then another plus 1/2 x. And then I have two -7, so -7, -7. All right, let's combine our terms. Well, I know that two x's make 2x, and then 2/2, well, that makes one whole. So what I have here is 2x's plus 1x, so altogether that's going to be 3x. And then I have two -7s. Well, both my signs are the same, so I add my numbers and keep the sign that's in front. Well, if I add 7 and 7, that's going to be 14. And since both of them are negative, it's a -14. So if I wrote an expression for this, it would be 3x minus 14. All right, we're jumping down now to number 15. It says simplify. Once again, I'm going to put all my like terms together. I'm going to start with my terms that have variables. This is a -2y. And this is a -8y. I put all the y's together. Now I'm going to go ahead and put my numbers together. This is 4, and since there's no negative in front of it, we know it's a positive 4. This is a positive 6.2. So I'm going to add 6.2. Now I'm ready to combine my terms. Well, remember, if my signs are the same, I add them and keep the sign that's in front. Since they're both negative, I know my answer will be negative. And 2 plus 8 is 10, so this is 10y. Over here, we got 4 plus 6.2. Again, if my signs are the same, I'm going to add my numbers and keep the sign. Well, both signs are positive, so I know my answer is positive. And 6.2 plus 4 is going to give me 10.2. So that's 10.2. And that would be my answer simplified. -10y plus 10.2. All right, let's go to number 17. Explain whether 11t minus 4t is equivalent to 4t minus 11t. Support your answer by evaluating the expression 4t equals 2. Well, I can tell you right now these two are not alike, and the reason is I have a negative sign in front of this term, -11t, okay? But over here, I have the negative in front of 4t. So that's going to give me completely different answers, but right now I'm going to state, because it says, explain whether they are equivalent, and see, they are not equivalent. Equivalent. I think that's how, yeah. Equiv. That's better. Equivalent, okay? They're not equivalent because the negative signs are not are not the same in each expression. Okay, now it says to support my statement, evaluating t for -2. All right, let's try that. If t is -2, if I do 11t minus 4t, well, that's going to be 11 times 2 minus 4 times 2. Well, 11 times 2 is 22. And negative 4 times 2 is minus 8. 22 minus 8 is going to give me, let's see here. I'm going to go with 16. Try that out. 22 minus 8. Yep. Borrow 1. That's going to give me, 14. I apologize, 14. Always good to double check your work, everybody. All right, let's see what happens when we use t in our second one. In our second one, we have 4t minus 11t. Well, that's 4 times 2 minus 11 times 2. Well, that's going to be 8 minus 22. That does not equal the same thing. Actually, that's going to give us the inverse of our first one, negative 14. Because we have the big number minus the small number, but we're keeping the sign of the big number, so that's negative. And that's why these two do not equal each other. All right, looks like I'm on the last one, number 19. Lucky for you, I've got the high order thinking question today. In the expression ax plus bx, a is a decimal and b is a fraction, okay? How do you decide whether to write a as a fraction or b as a decimal? Tricky. All right, so they're saying that I know in this one, a is going to be a decimal, okay? And b is going to be a fraction. And how do I decide whether to write a as a fraction or b as a decimal? Well, the first thing I want to think of is what's going to be easier when I'm doing my calculations. So it says if a is a decimal. Well, if I was to change a decimal into a fraction, the first thing I'd want to know is what type of decimal am I dealing with? If I'm dealing with a repeating decimal, let's just say like 0.3 repeating, okay? That would tell me it's a heck of a lot easier to go ahead and compute that if I turn it into 1 over 3, right? Remember, when there's a line over it, to convert it into a fraction, we put a 9 underneath it. So this would actually be 3 over 9. And 3 over 9 are both divisible by 3, so they become 1/3. So yeah, if it's a repeating number, I think I would want to change that into a fraction. Another reason I'd want to change it into a fraction possibly is if I see that the denominator of the second fraction, which is b, is going to be the same. Because if they're the same, that means all I have to do is add the top since I'm doing addition, right? Let's just say b was 4/3, right? And I had the, let's see, I had 0.3 repeating, right? Plus 4.3 repeating x plus 4/3 x, okay? I would say, okay, well, this is going to convert to 1/3 x plus, I can leave this at 4/3 x, and look, now my denominator is the same, and now it's just 1 plus 4, and that's going to equal 5 over 3 x, and that's going to equal 1 2/3 x. So you see, yeah, I can go ahead and get my denominators the same, or if I'm dealing with a repeating number, I definitely want to go ahead and deal with fractions. But in any other case, I think it would probably be easier just to take that second number, that fraction, and remember that every fraction is a division problem. Just take the numerator, divide it by the denominator, and then make both of them decimals, and I'd be fine. As long as I don't get a decimal with a repeating number, I think I would rather go the route as decimal. So that would be my answer. let's see, I guess if I was to write it out, I would put if I'm dealing with a repeating decimal, I would make it a fraction. Or if I could make the decimal into a fraction with the same denominator. Okay. And that would be probably the only reasons that I would go ahead and say that I would like to go ahead and change one number to another. Well, that is all of the homework for tonight. So I will see you in class. Have a great one.